Hey scholars, I hope this video finds you well. For today's lesson, we are going to start our triangle congruence unit by discussing some basics of triangles. We'll talk about how to classify them by their sides and angles, and then we'll talk about the Triangle Sum Theorem, which basically says that all the angles in a triangle add up to 180 degrees. So we're going to cover some basics before we move forward in this unit. So make sure you're taking good notes. Let's get started. So triangles are polygons that have three sides. A polygon is a two-dimensional figure that has straight sides, and triangles are three-sided polygons. So they can be classified by their side lengths or by their angle measures. So let's talk about how to classify triangles by their angle measures first. So we have four types of triangles when we're classifying them by their angles. So we have an acute triangle, which has just three acute angles. So for example, maybe this angle is 50 degrees, maybe this angle is also 50 degrees. Well, if that's true, this angle would be 80 degrees, which we'll talk about a little bit more when we talk about the Triangle Sum Theorem. We have an equiangular triangle because the angles in a triangle all add up to 180 degrees. Well, if all these are congruent, all these angles are congruent, then all these angles would have to be 60 degrees. Every angle here would be 60 degrees in an equiangular triangle. That's true every time. So we have three congruent angles in an equiangular triangle. Think equal angles, equiangular. A right triangle has one right angle, all right? And then an obtuse triangle has one obtuse angle. So we maybe would have a 100-degree angle right here, for example. All right, an obtuse angle being greater than 90 degrees. So that's how we classify triangles by their angles. Now, let's check out this triangle. Well, really, it's three different triangles. And we want to classify all three of the triangles in this figure. So we have the larger triangle, which we can say is triangle EGH. We have triangle EFH, one of the smaller triangles. And then we have triangle FGH. Alright, so I want to identify if they're acute, obtuse, right, or equiangular triangles in this figure. So I'll start with triangle EGH. Well, the angles of triangle EGH are 30, 60, and look, at H we have a 90-degree angle here. So because we have a right angle in that triangle, that right angle makes it a right triangle. So we'll say this is a right triangle. For EFH, well, it looks like we have an obtuse angle at angle F. Now we can find the measure of that angle. Here's a linear pair forming a straight line. You may remember that from Unit 1. If this angle is 60 degrees, then this angle has to be 120 degrees. Because these two angles, when they make a straight line, they have to add up to 180 degrees. Also, the angles in the triangle all add up to 180 degrees. So 30 plus 30 plus 120 adds up to 180. So we have one obtuse angle. So for triangle EFH, that's an obtuse triangle. For triangle FGH, we have two 60-degree angles. Well, 60 plus 60 is 120. Well, this angle also has to be 60 because the angles add up to 180 degrees. 60 plus 60 plus 60 is 180. So if all the angles are the same measure, which they're going to be 60 degrees, we'd say that's equiangular. Equiangular. All right, so we just classified those three triangles in that diagram. Let's move forward. Now, if we are classifying triangles by their side lengths, we have three types of triangles: equilateral, isosceles, and scalene triangles. Equilateral triangles have three congruent sides. And we'll talk about this more in the future, but when the sides are all equal, the angles are all equal as well. All of these angles are 60 degrees, so not only is it equilateral because the sides are congruent, but the angles are also congruent. So if it's equilateral, it's also equiangular. So equilateral triangle means it has three congruent sides. isosceles triangles have at least two congruent sides. We'll talk about this more in the future. This angle opposite here, angle opposite of that side is going to be congruent to the angle opposite of this side as well. Now, scalene triangle, none of the sides are congruent. And remember, the tick marks tell us that the side lengths are congruent. So now, let's classify the triangles in this diagram. So we have three triangles. We have the big triangle, ABD. We have another smaller triangle, triangle ABC. And we have another triangle, triangle ACD. All right, so for ABD, so the big triangle, it has side lengths of 15. Now, from this side length, this whole side is BC plus CD. Okay, so we have to actually add 15 plus 5 to get the length of BD. So that length is going to be 20. 15 plus 5 is 20. So the lengths of ABD are 15, 20, and 18. Well, none of the side lengths are the same, so it is scaling. So ABC. Now, we have congruent sides here. We see that they're both 15. But then this tick mark tells us that, well, if this is 15, this tick mark means that this must also have a length of 15 units. And so all the sides are 15 units, and that's going to make this equilateral. For ACD, we have lengths of 15, 5, and 18, so that is also a scalene triangle. All right, now let's try a tougher problem. We want to solve for x in this figure. Okay, well, I see that this is an isosceles triangle. So the two side lengths are congruent. So to find x, I can just set these congruent side lengths equal to each other. I'm just going to solve for x. I will add 1.3 on both sides, and I'll get 4x equals x plus 4.5. Subtract x on both sides. And we get 3x equals 4.5. Divide both sides by 3. We will get x equals 1.5. Now, let's check that by substituting in. 4 times 1.5 is 6. 6 minus 1.3 is 4.7. So I should also get 4.7 for this side length because they're isosceles. 1.5 plus 3.2 is 4.7. So this checks out. Our final answer is x equals 1.5. Now the last little thing that we'll cover in this lesson is the Triangle Sum Theorem. And I've already mentioned it several times in this lesson. The sum of the angles of a triangle is 180 degrees. So the sum of these interior angles of a triangle should add up to 180 degrees. So let's apply that on a couple problems here. So if we want to find the measure of angle T in this figure, what we need to do is we need to find the sum of angle A and angle M. So add those two angles up. So we'll say 27 plus 82, well that's 109 degrees. And we know they need to add up to 180 degrees. So we can just say 180 degrees minus 109 degrees is 71 degrees. So angle T, the measure of angle T, equals 71 degrees. And check that out. If we say 71 degrees plus 27 degrees, that's 98 degrees, plus 82 degrees, that's 180 degrees. So it checks out. Number 2 is a little tricky. We want to solve for x in this problem. Now, we know this is a right angle, so we know this is 90 degrees. So there's a couple ways we could go about this. We could say 90 degrees plus 2x plus 1 plus 5x plus 5 equals 180. Or we could just go ahead and subtract 180 minus 90. And that we know that's going to give us 90 degrees. So that means these two angles must add up to 90 degrees. So let's just add those two angles up. We can say 2x plus 1 plus 5x plus 5 equals 90. Okay, so now I'll just combine like terms. 2x plus 5x is 7x. 1 plus 5 is 6. And that equals 90. Subtract 6 on both sides. Get 84. 7x equals 84. Divide both sides by 7. X equals 12. Now, let's check this. So 2 times 12, I'm going to substitute x in here, right? 2 times 12 is 24. 24 plus 1 is 25. And then we have this degree symbol, so 25 degrees. 5 times 12 is 60. 60 plus 5 is 65 degrees. 25 degrees plus 65 degrees is 90 degrees. 90 degrees plus 90 degrees is 180 degrees. So that checks out. X equals 12. So there we go. We just applied the triangle sum theorem just with our knowledge that all the angles of a triangle should add up to 180 degrees. So I hope this video was helpful for you. I know a lot of these concepts probably all seemed familiar, but we're going to keep building on these and have more challenging problems in the future. So we need to make sure we have this foundation set before we do that. But come to class ready to ask questions and prepared to work. Good stuff today. Thank you, Collegiate Scholars.